You may have heard of how the speed of light is the ultimate speed limit of the universe, and yet Star Trek regularly breaks that rule. But are they actually breaking the rules? Well, the short answer is no. The Enterprise can in fact make it to Vulcan in a matter of days, rather than 16 years. But how is this possible? Well, let's first look at traditional rocket propulsion, with the rockets and stuff like that. Let's say you build a starship with super advanced rocket propulsion, with ultra-strong and efficient engines. The craft could accelerate to 99% the speed of light relatively easy, but as it nears the end of that final percent, the ship's mass becomes greater and greater. This will still affect you even in space. This would make the ship harder to accelerate. Even if you had ultra-strong engines that could accelerate the ship to 99.999999999% the speed of light, you won't get past that last final 0.000000001%. Let's look at the Enterprise, specifically the engines. Look at the back of the engines. Those certainly don't look like rocket thrusters, and since the impulse drive is actually at the back of the saucer section, it's not too far-fetched to assume that those giant tubes at the back are essentially Alcubierre drives that create a warp bubble around the ship. But what is a warp bubble? Well, imagine two identical motorboats, one powered by a traditional motor and the other controlled by a device that creates a depression in the water in front of it and creates a wave behind it. The Alcubierre boat will go significantly faster as it is riding the wave it just generated, and letting nature essentially propel it forward. This is not really that good of an explanation, but it's the best analogy it can provide to Terran-based minds. A warp drive effectively does the same thing the boat does to water, only to space-time. This might be harder to imagine, as space is three-dimensional, not exactly the place you think of riding waves. The Alcubierre drive, named after Mexican physicist Miguel Alcubierre, is designed for a warp drive consisting of a ring often around the entire spacecraft, which contracts space-time in front of it while expanding space-time behind it, creating the aforementioned wave. The warp drive is by no means traditional propulsion, as it essentially distorts space-time and moves the ship and space around it. Does this mean that you would feel the force of acceleration? Well, according to Dave Goldberg of Drexel University, you would feel absolutely normal, like you presumably would right now, assuming you aren't either in a car or on a plane. Why do we say on a plane? I'll do that some other week. Let's get back to the warp drive. So, to basically anyone who has watched Spaceballs and thought they were the only ones in science fiction to have the brains to include acceleration and deceleration effects, I'm going to give you a dose of rocket science. The extremely long Spaceball ship has three of what appear to be rocket thrusters, suggesting traditional G-force producing propulsion. But as the ship travels at ludicrous speed, which is faster than light speed, it would need to be a warp drive. It takes a few seconds to accelerate, but so does the Enterprise, and the bubble wouldn't make any G-forces. So if I got my calculations right, Spaceballs is the one that's wrong, or it could be me. One of us is going to be wrong. By the way, when I just said the warp drive doesn't generate any G-forces, I didn't mean any extra G-forces. I meant that if you were to travel at warp speed, you would be traveling at 0 G, meaning that you would be weightless unless you had a gravity generator. I should really be doing a video about gravity generators. So, is there a maximum speed limit in warp speed? Well, let's go up the warp scale and see what happens. Full impulse on most ships is about a quarter of the speed of light, or c. Warp 1 is exactly 1c. Warp 2 is 10c. Warp 3 is 39c. Warp 4 is 102c. Warp 5 is 214c. Warp 6, the cruising speed of Kirk's Enterprise, is 392c. Warp 7 is 656c. Warp 8, the maximum speed of a Klingon bird of prey, is 1024c. Warp 9 is 1516c. Now things are going to get distant from each other. Warp 9.2 is 1649c. Warp 9.6, the maximum speed of the Enterprise D, is 1909c, a speed that can only be maintained for up to 12 hours. Warp 9.9 is 3053c, so fast that the engines of most ships will automatically shut down after just 10 minutes, which is kind of a problem given that it still takes 655 years to go from the Milky Way to Andromeda. Warp 9.99 is 7912c, and now the Enterprise would require nearly infinite energy. Warp 9.9999 is 199,516 C, and its maximum subspace radio speed. What's subspace? I'll do that in another video. At that speed, you could cross the 10,000 light years of the Federation in just 6 months, and to Andromeda in just 10 years. Warp 10 is theoretically impossible to obtain, as the ship would occupy all points of the universe simultaneously if it managed to hit that speed. Now, I'm going to end this video with a quick warp speed safety tip. If you're traveling at warp and decide to go on a spacewalk, do not go anywhere near the edge of the warp bubble, as you'll be ripped apart and it won't be pretty. Thank you for watching this video. If you enjoyed it, please give it a like and share it with your friends and family. If you do, you'll be sending something at the speed of light, the data waves that make the information of the shared video notification. We don't usually think of it that way, but sending data is basically like sending a bunch of little enterprises through thousands of kilometers of wire. Now, if you excuse me, I'm going to spend the rest of Mother's Day with my mom, like it should be. See you on Wednesday.